our chapter is today integral calculus. We are discussing here indefinite integration, and we will solve one type of question. First I write the question so that you can understand what type of question we will discuss here. So write down this question. We have to solve integration 5x plus 3 in the denominator x square plus 4x plus 10. Okay, we have to solve this. Now first recall some formulas. These formulas are very important. Dx by x square minus a square, its formula is 1 by 2a log x minus a by x plus a plus arbitrary constant. Okay, this is first formula. Second formula is integration dx by a square minus x square. Okay, here formula is, here you have seen that if x square minus a square, then it is x minus a by x plus a. Okay, here it will be 1 by 2a, positive term will be on the numerator, a plus x by a minus x plus c, because here a is in the first term. So where a is the first term, in that case your formula is the positive one on the numerator and a plus x by a minus x. Okay, so I am describing it so that you can remember the formula easily. And the next one is, take the root here, integration dx by root over a square minus x square. Okay, its formula is 1 by a tan inverse x by a plus c. Now for integration dx by, this is for when in under the square root, here it is a square is the first term. Okay, and when x square is the first term, x square plus a square. Okay, or another term can happen that x square is the first term but here is minus. Okay, so in both cases we will get the formula almost similar, and that is log x plus root over x square plus a square plus c, and here it will be log x plus root over x square minus a square. Formulas are almost same for these two, right? They are same, just that if here it is minus, then it will be here also minus. Okay, so now these are the 5 formulas which are very important. Now we will see our question. Our question is that integration 5x plus 3 root over x square plus 4x plus 10. We have to solve this one. Now whenever in the numerator it is ax square, some notes I want to discuss, that whenever there is some form like in the numerator it is x square plus bx plus c, or in the denominator, here you can see in the denominator there is a term in this form ax square plus bx plus c, here abc are real numbers. Okay, so now in this case you can see in the denominator in this form there is a expression, and in the numerator its form is px plus q, like this. Okay, here p is 5, q is 3, and in the denominator it is ax square plus bx plus c. So whenever this kind of form, either this form can come or this type of form come is that px plus q by ax square plus bx plus c. means there is no root, no square root. In both of these form, what you have to do, you have to do that you transform this expression in some way, in such a way that its derivative should be this one. Okay, means basically you have to add something here or subtract something here, and you have to get its derivative in the upper term. Like its derivative can be anything, like kx plus r. Okay, and there are some constant you will get here. Okay, so in this kind of form we will get, then we can see what we can apply. So here we can, what we can do, that x square plus 4x plus 10. So what is its derivative? Its derivative is 2x plus 4, right? So basically we need 5x plus 3. We have to transform 5x plus 3 in 2x plus 4. So how to do that? So first what we need, that instead of 5 here, instead of 5 we need 2 here. So what we can do, that 5x plus 3 we can write like this. We can write like this: 5x plus 3, okay, 5x plus 3 equal to, so basically I need 2x plus 4. Okay, so 1 2x plus 4 means if I have to eliminate 5, then I have to divide it by 5, right? So for dividing, I have to divide it by 5, or we can take common. We can take common here 5. If we will take common here 5, this will be x plus 3 by 5, right? Now I need 2 here. So I have to multiply by 2. So if I have to multiply by 2, means 2x plus 6 by 5. So in that case I need 2 here also, because I cannot multiply 2 without dividing here. Means basically here we have taken 2 by 2, so that expression doesn't change. Okay, so here already we get 2x, but I need 4. Okay, so if 4 is needed, so what we can do, 5 by 2 into 2x plus 4 minus 4. Okay, so 2x plus 4 is okay. Take this term outside. Okay, so it will be, take plus 5 by 2, 6 by 5 minus 4. So 5 by 2, 2x plus 4 plus, simplify it. So it will be, in the denominator it is 5. So it will be 5 4 20. So 6 minus 20 means minus 14, right? 5 cancel out, it will be 7. So that means 5x plus 3 transform into 5 by 2 into 2x plus 4 minus 7. Okay, so now write the integration here. Integration 5x plus 3 root over x square plus 4x plus 10. Okay, so now you can write, instead of 5x plus 3, here you can write 5 by 2 dx. I didn't write here dx. Okay, 5 by 2, 2x plus 4 minus 7. Okay, Now you can understand why we are doing this as its derivative. It's this term, why we are taking this term derivatives as in this expression here. You will understand it. So first thing is that, so here now I can write like this. Okay, I am writing from here, equal to 5 by 2 integration 2x plus 4 by root over x square plus 4x plus 10. Okay, I can write like this because this is one expression, this is one expression, and sorry, this one is one expression and this one is another. Okay, so I can write like this. So I can integration 7 dx by root over x square plus 4x plus 10. So now we got two integrals here. This is the first one, this is the first one, and this is the second one, right? So why we are getting like this, that we will understand. Sorry. So we can see here that in this expression you can see that this is the derivative of this term. Okay, and we can write it easily like 5 by 2. Okay, so if I put here that put here, take here first as I1 I2 so that space can be used, because if you will take two terms together then it will be little bit lengthy to write. So that's why we can take it as, this is first integral I1, you can take it as I. Okay, the whole integral is I, you can take it as I1, this one as I2. Okay, now our I1 is 5 by 2 integration 2x plus 4 root over x square plus 4x plus 10. Now put here x square plus 4x plus 10 equal to t square. Okay, so if I take here t square, here what we are doing, we are using substitution method. Okay, so just do the derivative on the both sides. So we will get 2x plus 4 into dx equal to 2t dt, right? So now you can easily put here this substitution. This is what, root over x square plus 4x plus 10, this will be t, and in the numerator it is 2t dt, right? 2x plus 4 dx is equal to 2t dt. Now you can see that this integration simplified in a very simple, very short form, means now we can do the integration very easily. So we can cancel here, tt, right? So we are getting 5 by 2 integration 2 dt. So we can write 5 by 2 into 2t plus c. Now you can put here, you can take c on the outer side also. So you can put here c outer side, 2t plus c. So 2 can cancel out. Now t is what? T is actually root over x square plus 4x plus 10, right, plus c. Okay, so this is your value of the I1. Now we will see I2. Okay, so what is I2? I2 is integration 7 by root over x square plus 4x plus 10 dx. Now I have said at the first that whenever you will see this kind of term, either this kind of term in the denominator, it can be square root or it can be no square root. So in both the cases, what you will do, you will take this term as the derivative of the denominator. So here you can see that this is not in that case, it is not in px plus q form, right? So if it is not px plus q form, so in that case we don't need to do the derivative process. So what we need to do here, when only you will get this kind of terms, like only in the, it can be dx by x square plus bx plus c, okay, like this, or it can be some constant can be in the numerator, but it doesn't matter that much, or it can be dx by root over x square plus bx plus c, okay. So in both these cases, what we will do, we will transform this expression x square plus bx plus c in some square form, okay, in some square form, and obviously there will be some constant terms, and if there is any constant term, like there can be anything, like there can be 8, then we can write it as root over 8 whole square, okay. So we will take its square also. So basically first we have to make this expression as a square form, okay. So that we have to do. Now you will see how to do it. So integration, you can take 7 outside here, because here the constant doesn't matter. So if you need square root here, so obviously you can see x square plus 4x, okay. So x square plus 2 into x into 2. So if I need some whole square, so obviously I need these terms square, right? So basically we can add here 4, okay. Now it can be written as x plus 2 whole square. So basically from 10 we have take 4, means what left is 6, okay. So now we can write integration dx root over x plus 2 whole square plus root over 6 whole square, right? So is this a standard form of those integration what we have discussed at the first of this video, right? This is actually, if I put here, so for your useful thing, what we can do here, put x plus 2 equal to, what we can put here, you can put here r, okay. So it will be take derivative on both sides, so it will be dx equal to dr. Constant term derivative is what, 0, okay. So dx equal to dr here, so you can put here dr root over x plus 2, in the place of x plus 2 you will put r, so it is r square plus root 6 whole square. Now see, this is in what standard form, you can see that this is in root over r square plus root 6 whole square, so this is in this form, right? There is plus between x square plus s square, there is plus, okay. So here our format is this one, okay. So this formula we can use directly, okay. So now use the formula. The formula is, according to the formula, the integration is log, because here variable is r, so we will take r plus root over, in the root the same expression again we will put here, that is the formula. So it is r square plus root 6 whole square, means we can write 6 here, plus c. So here, because constant is 2 here, c1 c2. So at the last, because these are arbitrary constants, so it doesn't matter, whatever we add still it is arbitrary, because we cannot know what is the constant value. So now put the r, value of r, 7 log x plus 2 plus root over r square plus 6. Now you can see that one thing you can see, these r square plus 6 is actually come from where, from here we have transformed this, and this this expression comes from which expression? This one, because it is not changing, just his expression, his way, its way of representing is changing. So basically x plus 2 whole square plus root 6 whole square is actually x square plus 4x plus 10. I just transform it so that I can get a standard form and I can use the direct formula. So that's why I have done it. But you can write directly here, if it is r square plus 6, r square plus 6 means x plus 2 whole square plus root 6 whole square, and that means it is equal to x square plus 4x plus 10. So we can write here root over x square plus 4x plus 10 plus c2. Okay, so we get both I1 and I2. So our integration is I equal to I1 plus I2, right? So now what is the I1 value? I1 value is 5 into I1 value is 5 into root over x square plus 4x plus 10, right, plus c1 plus I2. What we'll do for c1 and c2, c1 and c2 we will add, so we can write as c1 plus c2 equal to c and another arbitrary constant. It doesn't matter because we don't know what is the constant, that's why it is arbitrary. So we can take c here. Now so root over x square, now put the value of I2, so it is 7, it is 7 log x plus 2 root over x square plus 4x plus 10, okay, plus c1 plus c2, I have taken c here, okay. So this is your answer, this is your required answer, this is the required value, okay. So in this way you will solve this type of question. I hope all of you understand. If you will practice this type of question more, it will be more fluent. It will be lengthy, but that not that much lengthy. When you will practice almost 10 to 15 questions, it will be more easier.